All right, alternating series remainder, okay? So we need to make sure that alternating series satisfies the conditions for AST. So we need to take off the alternating part. We need to figure out if my limit goes to 0, okay? So we need to make sure it converges to do anything, all right? And then this is the way our remainder goes, all right? So our remainder is our actual sum subtracted from our partial sum, or our partial sum subtracted from our actual sum. And that's what the remainder is, okay? And so what I want you to write down is I want you to think of it as the next term, all right? So the actual sum of whatever it is going to be less than the next term, all right? And so that's the remainder part of it, all right? And then we can make an interval. We can add whatever our partial sum is, our remainder, to our, and we need to subtract it. So we need to add and subtract, and that will give us our bounds of our actual interval in which our sum will lie. All right. I think after doing one, I think we'll come into play. All right, here we go. So we're going to approximate this sum using the first 6 terms and find the error. All right. So we're going to find the first 6 terms. So let's substitute in 1. What do we get when we substitute in 1? 1. Good. All right. And then what's my next term? I substitute in 2. So now I'd have negative 1 up top and then 2 factorial on the bottom. What's 2 factorial on the bottom? 2. So now I have minus 1/2. So my second term is minus 1/2. Yes? All right. So then what's my third term? Now I'm going to have plus 1 over, what's 3 factorial? 6. Minus 1 over 4 factorial, which is 24. And then plus 1 over 120, that's what's 5 factorial. And then what's 6 factorial? Minus 1 over 720. Now, that's the first 6 terms, okay? And so that's what I'm trying to find, the sum of that. And then we're going to find its error. And so its error is actually the next term. So let's find the next term. So now it'd be plus 1 over, I substitute in 7. And so 7 factorial is 5,040. And so that is my remainder, or my error. All right. And so we're going to find our sum, sub 6. And so this is where we use our calculator. So we're going to substitute those in to our calculator. Sub 6, which would be what? 91 over 144. All right. And so my error, my remainder, its maximum remainder would be 1 over 5,040, because that's my next term. Does this make sense? Because what's happening is when I go to 0, I'm trying to do this for Susie instead of doing it on the board. I'm alternating like this, remember? And it's getting closer and closer to 0. Yes? And so what's happening is I would have minus 1 over something more than 5,040, all right? And so it's getting even closer. So my maximum error for my remainder is this portion right there. Because if I go a next term, will I be even more accurate? Yes, but the maximum error that I could have is 1 over 5,040. Does this make sense? All right, and so what we're going to do is when we find our interval in which our sum might actually lie, is we're going to add 1 over 5,040 to my upper bound, and we're going to subtract 1 over 5,040 for my lower bound. So my sum is actually going to be equal. So my lower bound is what? 199 over 315. And then my upper bound is actually 177 over 280. All right. And so that, all right, so now we're going to approximate this sum with an error less than 0.001. So again, this is calculator heavy. This would kind of stink. Actually, this one wouldn't be too bad without a calculator. All right, so let's go. Let's go term by term. We substitute in 1. What do we get? 1 over 1. All right, we're going to call that 1. And then minus, we substitute in 2. So now we have 1 over 16. Now we're going to substitute in 3. So now I'd have what? Plus 1 over 81. Now, what is this error thing? What is an error less than 0.001? What is that in fractional form? 1 over 1,000. So I am looking for a number smaller than 1 over 1,000. Is everybody following me on this? All right, cool. So then so are we there yet? Not yet. All right, so now we're going to substitute in 4. So what's my 4th term? Minus 1 over 256. All right. And then what is my 5th term? 1 over 625. Are we there yet? No. All right, what's my next term? 1 over, what? 1296. Are we there yet? Yes. So this term is my what? My remainder. That is my remainder. Now, how many terms did I get my sum to have a remainder less than 0.001? 5. I had 5 terms. So my S sub 5, I add those together. 0.9475. All right. So my sum of my first 5, my 5th partial sum, would be 0.9475. And so my remainder, my R5, okay, it's not called a 6th. It is my 6th term, but is my remainder sub 5, is less than or equal to this 1 over 296, 1,296, all right, which is less than what? What did I want it less than? This 0.001, all right? And so my remainder is going to be less than that 0.001, all right? Pretty good? All right. All right. For our ratio test, this will definitely be on the AP exam. All right, they do this a lot. So on the ratio test, this is what happens. We do our next term over the previous one, okay? And so that's how we can test using our ratio. And so we add 1 to the nth term, and then we divide by the original. And what we want is we want it less than 1, okay? Now, I will not divide. What will I actually do? I will multiply by its reciprocal, okay? And so if it is greater than 1, it diverges, all right? So if we do our next term over one another for a limit to infinity, and if it's greater than 1, it diverges. So everything's good in the hood there still. However, if it is equal to 1, the test is inconclusive and your life really sucks, all right? We don't want it to be 1. It's really painful when it is. All right, we will actually do 1, Nick. Not today, but we will get to 1. All right, sound good? So if it's less than 1 for our next term, we're going to take a limit to infinity of our division statement. Then what? It converges by ratio. If it is greater than 1, it does what? It diverges by ratio. Okay? All right. All right, so a lot of the times when we use ratio tests, it's with factorials or exponentials. That's kind of a key of when to use this test, okay? All right, so that's kind of the giveaway. Let's look at this one. So now I have 2n over n factorial, and I need to find if this converges or diverges. So what are we looking at? We're looking at an exponential with a factorial, yeah? What should we test for first every single time? Nth, okay? Who wins? The bottom wins. So does my limit to infinity go to 0? Yes, okay, so I should keep going, all right? And so I see exponential and I see factorial. That leads me into using ratio. So now we're going to do a limit as n approaches infinity. Do you want me to do the fraction on it first, or do you want me to just do straight up? You want me to do fraction first? All right. All right, so now we're going to add a term. So now I have 2 to the n plus 1 over n plus 1 factorial. Do you see how I added my next term? And then it's over 2 to the n over n factorial. This will be the only time I actually do this, all right? Because really, I want you to jump straight there, all right? What am I doing when I divide by a fraction? I multiply by its reciprocal. So my next term, I'd end up with this 2 to the n plus 1 over n plus 1 factorial, and then times n factorial over 2 to the n. Okay, so I'm going to jump there from now on. Okay, all right, so now we have to use a little bit of math. So 2 to the n plus 1 is really what? 2 to the n, and then what? Times 2 to the first. Does everybody understand how that works in mathematics? All right, and then this n plus 1 factorial is really what? N plus 1 times what? N factorial. And then I still have n factorial over 2 to the n. Because now what can I cancel? The n factorials. What else can I cancel? 2 to the n's. All right. And so what am I left with? 2 over n plus 1. So now I'm going to take a limit as n approaches infinity of 2 over n plus 1. And what do we get? We get 0. And what do I want it to be? I want it to be less than 1. All right? And so is it less than 1? Yes. So what do we know this summation does? It converges. Now tell me why. By ratio. All right. Pretty good? All right. Let's do it again. So now I have n squared over 3n plus 1 over 2 to the n. If you truly understand speeds, you should kind of stop. What happens? The top wins. Why does the top win? I have a 3 to the n over a what? A 2 to the n. The 3 to the n is going to win. So everybody follow me on this. So this one does what? Diverges. We could almost be done now. I'm going to actually do this problem because I want to practice ratio. But this one diverges why? By nth. We're going to actually diverge it by ratio too in just a second, but this one diverges by nth. All right? All right, so now we're going to practice. So now we have a limit. As n approaches infinity, we're going to get the next term. So now we end up having n plus 1 squared times what? 3 to the power of what? N plus 2 over 2 to the power of n plus 1. And then times 2 to the power of n over n squared times 3 to the power of n plus 1. All right? I personally just multiply by its reciprocal right away. It's truly a fraction, however, I think it's redundant. All right, so now this is where we look at. So now if I have n plus 1 squared and then I have n squared, what happens there? As my limit as n approaches infinity. Do I care about the 2n plus 2 thing going on? No, I don't care about that. So this is really just an n squared over an n squared, right? And so that part goes to what? 1. This part goes to 1. So everybody follow me. All right. All right, so that part goes to 1. And then what am I left with? I have 3 times, or 3 to the power of n, and then times what? 3 squared. All right. And right down here I have 3 to the power of n times what? 3 to the power of 1, right? And so what am I left with these two terms? I'm left with 3 up top. All right, so that leaves me with 3 up top. And then on the bottom, I have 2 to the power of n plus 1, which is really 2 to the power of n times 2 to the power of 1, right? And then I have 2 to the power of n up top. So what am I left with here? I'm left with 2 on the bottom. And so I get my limit to infinity as 3 halves, which is what? Greater than 1. When it's greater than 1, what do we know? It diverges by ratio. All right? So you could actually use ratio here. However, I think if you understood speeds well enough, it diverges by nth. All right? All right, let's look at part C. We're going to do the same thing, basically. What should you use first every single time? Nth. All right? And so what happens? Who wins? Top. Why does top win? Factorials are faster than exponentials. Did everybody follow me? So if you truly understand speeds, this one does what? Diverges by nth. All right? We're going to practice ratio because I want to. All right? So we're going to do it. So now I have a limit as n approaches infinity of what? N plus 2 factorial over 3 to the power of n plus 1, and then times what? 3 to the n over n plus 1 factorial. Does everybody see how that worked? All right, cool. So now, what is this 2n plus 2 factorial? That's really what? N plus 2 times what? N plus 1 factorial. So what's left in the numerator? N plus 2. All right? And then what's left in the denominator? A 3. And so now, what's my limit as n approaches infinity of this thing? If I substitute an infinity here, my top is going to win. And I get what? Infinity. Is infinity greater than 1? Most of the time. All right? And so infinity is definitely greater than 1. So what do we know? It diverges, why? By ratio. All right? But if you truly understand speeds well enough, that diverges by nth. All right? Pretty good? All right. One more test. One more test. Here's a root test. All right.
Is this the last test?
This is the last test. This is the last one. This is the ratio test. And ratio and root go together. All right? But you can use ratio for everything. Does everybody follow me on this? You can use ratio and you don't actually need to use root. However, root is sometimes a shortcut. Okay? And they follow the same pattern. And so for a root test, you nth root it. And when you nth root it and you take a limit to infinity, you still want less than 1 and you can get converging. All right? If you nth root it and you take a limit to infinity, you get greater than 1. It diverges. When it equals 1, your life sucks. All right? It's inconclusive. You got to try something else. All right? Seriously, you don't want that. All right? So this is kind of a shortcut sometimes when they're exponential. All right? All right, so let's look at this one. So now I have a summation. All right? First of all, what should we try first? What should we try first every single time? An nth. All right? Does it pass the nth? For sure. Okay, who wins? The bottom wins. Into the end is really fast. That's the fastest you can get almost. All right? And so it's going to beat out an exponential. However, you should manipulate the way this looks. All right? How could you manipulate the way that looks? There it is. All right, so this is a summation of e squared over n to the power of n. And so now it's not geometric. The reason why it's not geometric is I have a variable in this denominator. Okay, does it look similar to a geometric though because it's raised to a power of n? This e squared is a number, but then I have a variable. So we can root out the exponent. And so we're going to nth root it. All right, and so when we nth root it, now I have a limit. I shouldn't have put the root there. Yep, too bad. It's there now. So now I have a limit as n approaches infinity of the nth root of e squared over n to the n. And so what am I left with? E squared over n. So now I have a limit as n approaches infinity of e squared over n. And what does that become? 0. Okay, the bottom wins. And what do we want it to be? Less than 1. So 0 is less than 1. Yay. So this does what? Converges by root. All right. I want to prove something. All right. Could you use ratio on this? You could. All right. It's gonna make you think a little bit harder, but you could use ratio. All right. All right, let's look at this next one. So now, do you see how it's raised to a power of n? It plays really nice. However, if you truly understand nth test for divergence, we could maybe stop here. So if we substitute in infinity, what do we get? 3 halves to the power of what? Infinity. What's going to happen? It gets real big. And so what do you know? It diverges how? By nth. Now, we're going to prove a point. We're going to use root test. All right. However, this also diverges by nth. All right. So now I have a limit as n approaches infinity. I'm going to nth root this one. All right. So now I'm left with the limit as n approaches infinity of 3n plus 4 over 2n. And so what do I get? I get 3 halves. And what do we know 3 halves is? It's greater than 1. So when it's greater than 1, what do we know? It diverges by root. All right, but I would also accept diverges by nth if you truly understand nth test. All right, pretty good. All right, there's day 3 and day 4 in your homework packet. All right, so I would like you to finish those by Thursday. All right, on Thursday we will have some review time. Okay, so we'll be reviewing this as well as what also is on Thursday. Barron's chapter 5. All right. Wednesday, Susie.